Good afternoon, everyone. I think this is one of our last sessions, so bear with me, and it's going to be a brief talk. We'll open up for Q&A and discussion. So good afternoon. My name is Chula Hu. I'm the Director of Generative AI Engineering and a Principal Solution Architect at Booz Allen Hamilton. Booz Allen is a leading AI service provider to the U.S. federal government. We are also a proud AWS partner in the Gen AI Innovation Alliance program, certified with AWS Gen AI and MLOps competency, and a sponsor of this week's Golf AI event. In today's session, I'm excited to share some of our experience building Gen AI solutions to enhance citizen experience with Amazon Bedrock. So like all artificial intelligence innovations, generative AI and large language models are not a single technology breakthrough. We've been at the forefront of Gen AI and large language model research since its emergence, and have developed and deployed many machine learning and deep learning solutions that kind of serve as the foundation of this AI technology. However, it is important to recognize key differentiating characteristics and the different ways of interacting with these models as compared to traditional machine learning methods. Typically, LLMs are pre-trained on broad and massive amounts of data. This type of foundation models can be applied across a wide range of use cases. They're highly adaptable, can interpret nuanced language constructs, but as a result, also require very careful control and steering to reliably perform a task. Some of the common customization techniques, we hear today include all the way from continuous training, transfer learning, or fine-tuning with domain-specific data sets, prompt engineering, and also very commonly today now providing more directional context through retrieval augmented generation, or RAG. And this list continues to evolve and continues on. But it is important to recognize that a highly functional generative AI solution requires engineering across each layer of the technical stack. Some of the essential components of the stack include integration of use case-driven applications, advanced model selection, and customization via mission-specific data, the data pipeline required to pre-process those data, get them ready in a state to be consumed by LLMs, prompt templates, agentic workflows, which is really emerging and starting to take the lead in all of the application development today, and reliable infrastructure, of course. We often find successful solutions carefully analyze existing human-based workflows, and then leverage well-designed orchestration frameworks and systems to automate or enhance some of those processes. Of course, a measurable, responsible, and reliable AI system also require implementation of responsible AI guardrails. As mentioned before, these large language models can hallucinate and can go off track because they are, in nature, probabilistic. And also, of course, LLM operations. Once you deploy the application, how do you repeat that process of deployment? Maybe building infrastructure as code, monitoring and logging while it's in operation. So there are many citizen service use cases that can be addressed by building upon Gen AI's core capabilities. For example, automated data augmentation, text, audio, image, video, you name it, code generation, different modalities today, as well as enhanced search and summarization, which are very common. So for customer service or help desks, advanced chatbots can be trained to fulfill time-critical, response-constrained customer service functions. Powerful natural language processing tools can help researchers and scientists search, aggregate, and summarize the most relevant information, extracting critical insights, finding that needle in the haystack, or remove the haze altogether. For many citizen services, LLM-based policy assistance can dramatically accelerate and improve decision support for federal employees to adjudicate claims, access policies, and check for compliance, which we'll see a more detailed case study for that later. In other scenarios, generative AI technology can serve as an effective kind of co-pilot for IT engineers and developers to interpret and migrate legacy code bases. It can provide real-time analysis of logs to detect anomalies, for example, and automated alerting, response, and patching. Also, as the complexity of Gen AI systems and workflows continue to evolve, agencies can leverage these technologies to enhance strategy research, scenario planning, or in certain scenarios, operation planning, course of action planning with multi-agent systems. In these systems, right, each agent, technically model, plus some kind of tool sets they have access to, has specified set of skills and tools it can access or even create to be able to reason, plan, and execute tasks in an ecosystem along with other agents and also, of course, human feedback loops. In this next section, I will quickly walk through 3 example use cases and illustrate how a solution can be built using Amazon Bedrock and other development tools provided by this platform. In the first scenario, federal benefits program often deal with a staggeringly large number of claims. They must hire and train new claim processors rapidly and update current staff on new policy. A retrieval augmented generative AI tool can help search for appropriate legislature with natural language prompts or user queries, provide rating or adjudicated decision recommendations, as well as the source information and justification for such response for further human review. This solution not only reduces the time required to process these claims, but also can reduce variability in decision making by directly associating and citing policy, right, with each claim decision. Sometimes today it's very humanly objective. And this next slide is just a very simple view of a potential reference architecture, right, for such application for benefit assistant. On the top is the data ETL process to ingest data via an SQS and a Lambda-based pipeline to create embeddings with Bedrock embedding model, for example, Titan, and then store into AWS Bedrock, OpenSearch vector database. For user queries, for example, it could be many different user interface, but a web application can send the user query to the same embedding model and then perform vector similarity search against pre-indexed policy document embeddings. The most relevant document chunks are then retrieved and added to user query in the final prompt to a Bedrock, for example, generative LLM, to provide a response and source citation to the user. For efficiency and context preserving, what's also shown in the query box on the top, right, commonly asked and most recent chat history can be stored and retrieved for additional context. Now, in this second scenario, a public healthcare agency has vast amounts of data and complex documents that clinicians and healthcare workers need to review frequently. They often have to manually extract information from various patient forms, charts, text, scan images, tables, and then enter them into electronic health systems. These documents can also be in multiple languages and formats, right, making that process extremely labor-intensive and error-prone. A healthcare document processor may leverage a combination of domain expert models and large language models to extract healthcare-specific named entities, relationships, produce summary of lengthy, complex documents, and create key insights from multiple data sources and sometimes of different modalities. This tool can reduce manual effort and free up clinicians' time to focus on more critical diagnostics and treatment tasks. Now, in this next reference design, it showcases how an ensemble of intelligent document processing technologies and services can be integrated to perform such tasks. Namely here, right, Amazon Textract for optical character recognition, section detection, Comprehend for name entity recognition or other text analytics required, and an Amazon Recognition or self-hosted vision model on SageMaker for your image analytics. An Amazon Bedrock LLM can be used for hierarchical summarization and information aggregation. And all of that will be documented in the final, either it's a JSON format output or document to be viewed by the doctors. And finally, in this last scenario, we look at how a multi-agent generative AI system can help agencies create reports, training materials, handbooks that are high quality and compliant. A Gen AI report co-authoring application here, right, leverages LLM agentic workflow and NLP techniques to translate requirements and domain-specific instructions into, for example, coherent outlines and key points. Normally it starts with very high-level and vague requirements, but then you can upload additional documents with formatting, compliance, and even like past experience of how you normally draft such reports, right? It can generate complex content based on your data sources, provide editing and improvements in styling, clarity, and compliance. So as illustrated in this graph here, the system may contain multiple agents, right, performing different writing or editing tasks who can communicate and collaborate via a orchestration engine. So you have someone that sends out, when I say it's agent, send out different tasks to outline agent generate the outline and then pass over to research agent to kind of create that Q&A loops of what question I want to answer in this section. And by interacting with the model, it will generate content and you pass over to a writer agent that will write out the content. And finally, when the draft is done, in a normal document drafting, you have a review board and you have review agents who will look at the style, whether it's complying with the requirements and etc. to complete the final draft. And this is a very simplified view of such systems as a reference architecture. You can see an example ETL process to ingest indexed organization's context document using various managed services. And then really the central, like the brain, is the Bedrock LLMs, right, interacting with context vector databases, open search, and RAG tools to perform these tasks via this orchestration system. So this last section, as mentioned earlier in the tech stack, governance and responsible AI are both critical components in a Gen AI solution. This is especially true in the public and citizen service sector, where each application potentially touches millions and directly impact, right, humans' lives. So Gen AI technology carries specific technical and ethical risks. Some commonly known issues include, I mentioned earlier, hallucination, inaccurate responses, misuse, or bias patterns. Equally important is awareness of risks associated with IP infringement, data privacy concerns, data leakage, model security against adversarial attacks. For example, most government agencies today, right, treat the improper uploading of sensitive data to public Gen AI systems as a data breach and are beginning to tie it into a reporting requirement to security operations centers. So our approach to responsible AI is comprehensive, covering safety, governance, and ethics, and quantitative at the same time, providing step-by-step guidance to jumpstart our AI practices, quantitative analysis of ethical rights and safety impacting risks, as well as training and integrating with industry-leading AI governance tools in every application we develop and deploy. So we have been fortunate to be able to work on some of the most challenging and impactful projects with our clients and are excited to partner and co-develop solutions with AI industry leaders such as AWS to better serve our citizen services and other federal agencies in their missions. Very excited for what's coming in this technology area, and we'll continue to lead the innovation and responsible implementation of these technologies. So that's all the content I have. Thank you. If you have any questions or would like to learn more about our capabilities, we have a booth 470. It's like all the way in the exhibit hall, and check out boozallen.com/GenAI after the event. I'll be at the booth with the Booz Allen team for any questions, and you can see our amazing demos on some of the use cases I mentioned earlier, intelligent health data processor. We also have demos on cyber vision, responsible AI, AI security, and more at the booth today and tomorrow. All right, thank you. So I think we have plenty of time. Do we have any questions from the audience, or we can take offline as well? All right, I think we're good to end today's session. Thank you for coming.